PhD, Professor of Marketing Emeritus at University of British Columbia, Southern School of Business. Since he joined the school in 1979, he has won university-wide awards for both his research and for his teaching accomplishments. In 2008, he has selected as an inaugural fellow of Informed Society for Marketing Science. He has served as an area editor for Marketing Science, as co-editor for Marketing Letters. And his research interests includes analytical techniques and mathematical modeling in marketing, economics of the arts and entertainment industry, marketing in public and non-profit organizations, and marketing for sales, for safe and healthy behaviors. So it's a very honor to have you here, Professor Chuck. Sorry, Professor Charles.
Professor Weinberg.
Hey, whatever you call me, I'm here.
Very sorry for the names.
No problem.
But it was an honor to have you here. I just met you when I was in UBC. I was there when you for all the ceremonies for your retirement, and that was very, very, very interesting to see how they treat and how you get the honors to be there for a long time. So thank you very much to be here, and we just to let you know how we work here. Professor Dani Clara will be the moderator for this talk, and we probably have more people listening for your talk. So if you have any questions, please put your question in the chat, and we can interact on the beginning, on the end of the talk. Okay. So thank you very much, Professor Weinberg.
Well, thanks very much. I appreciate that introduction. And as I said, I wish I could be in Brazil right now. I'm sure everyone wishes we could all be together in person, but this is the reality of the modern world. So we've all getting used to video and Zoom and things like things of that sort. So the work today is entitled, as you can see, Threats to Privacy versus Savings Money. And we study this in the context of what's called usage-based automobile insurance, or UBI. This is joint work with Miramad Soleimanian, who's a professor at Simon Fraser University, who's actually on the Zoom link as well as Ting Zhu, who's at Purdue University. And if she can, she'll be joining us later. And so once again, I'm going to take you through the work that we're doing. To start out, I want to talk about just what usage-based insurance is. It's recent, about 10 years or so, innovation in the auto insurance industry, in which basically automobile insurers are able to monitor your driving behavior. So if you agree to buy UBI type insurance, then you plug in a small device. You can see in the picture to the typically below your steering wheel. You can picture it as sort of like a thumb drive, a small drive, and you can then plug it in. It's fairly easy to do, and then that uses what they call location-based services to monitor exactly where you drive, when you drive, and so forth. And so then it keeps track of where you go, knows when you start, knows when you stop, so it figures out how many miles per hour you're driving, how many total miles you're driving. It's real-time monitoring. It's an example of connected devices, so that we know how much you drove when you're using this. We know whether or not you hit the brakes hard, and hitting the brakes hard. Whenever you hit the brakes hard, the device issues a beep to inform you that you hit the brakes hard. And perhaps and we found in previous work that you do learn from those beeps that you shouldn't be doing that. It says where you're driving. So if you're sort of sneaking out of the house at 2, 3 a.m. in the morning, you'll be monitored, so it'll know that. People might not want that to be known, as well as rapid acceleration. So this is an example of what are called connected devices, do real-time data tracking, and they provide new opportunities for marketers to provide different types of personalized marketing activities. generates new types of data and new types of privacy concerns. Why do people agree to be monitored? Well, they agree to be monitored because it provides real benefits to them. The benefits to them most directly is to lower their premium costs. Because if the automobile insurance company knows how well you drive, they can adjust the cost to what your actual driving behavior is. In general, at least in North America, and particularly the United States, where our study is based, that when you get a quote from an automobile insurance company, they know things about where you live, whether or not you live in an urban area or rural area, whether or not you drive your car to work, and some other general things about you, how long you've been driving. You know, younger drivers tend to have less driving experience, so they tend to get rated more highly, or more challenged. And so by signing up for this device, you get an opportunity to lower your premiums, because everyone thinks they're a better driver than other people say they are. And so you can actually lower your premium, because the premium can be based on what your actual driving behavior is, not just a broad estimate based on class. And in addition, it has the benefit, and we've shown that in a previous study, that when you are monitored like this, you become a safer driver. And because you become a safer driver, you're less likely to have accidents, which is obviously not only beneficial to you, but to society in general. Now, UBI, like other Connect devices that allow for personalized marketing, also provide benefits for the insurers. First of all, the same advantage to them. They get better assessment of risk, what your risk is, so they can target their pricing more directly to you. Safer driving, fewer accidents. That's great for their claims history. And in addition, they think, and we'll show some data on that, that it increases the retention rate of customers. That when you put this device in the car, that you have to sort of sign up for the program, get the device, install it in your car, and then you can allow it to stay in your car for up to 6 months. I'll talk about that in a little more detail in a couple minutes. So there's some nuisance or switching costs. So they feel that once people do that and they get a lower rate, they're more likely to stay with the company. So now, as I said at the outset, there's a tension between these types of connected innovations that rely on the use of private data and the protection of your own privacy. So that's the tension that exists. You see some benefits, but you're giving up access to information that you previously thought was private. The paper I'm going to present today, the middle one, is one of 3 papers that we're doing in a series. We've already published one paper which looks at privacy effects, which looks at safer driving. And we've already, as I mentioned, when you're being monitored and even after the monitoring ends, people tend to be safer drivers. So we demonstrated that, which is, I think, one of the first demonstrations from having this monitoring behavior of being a safer driver. You can sort of view this as really like a Fitbit for cars. The second paper, which I'll talk about today, is how consumers trade off the advantages of being monitored versus their threat to privacy. So I'll talk about that in a couple of start pretty soon. And then the third paper, if you're being monitored, then you typically get a lower price, but you also get better information about what type of insurance coverage, what type of better your driving ability. And so then how does this affect your future insurance choices? Do you tend to, suppose you find out you're a better driver, do you buy more insurance because you just want to be, it's cheaper to buy it? Or you do buy less insurance because, well, I'm really a safe driver, so I don't need insurance or as much insurance. So you have that. And also, are customers more willing to buy other products from that company? So that's the third research project, but we're going to focus today on privacy. So privacy is clearly an issue. Various countries have different legislation about privacy. People are clearly concerned about it. If you do surveys of people, they're reluctant to engage in different activities. An early paper looked at asked people about their willingness to share their medical records digitally, and there's a hesitancy because of privacy. A lot of services, well-known companies provide online targeted advertising. They customize the advertising to who you are, Google search, and so forth. But a lot of customers or users of the internet feel reluctant to do that. And then in a very recent paper studying smartphone apps, that a lot of smartphone apps have two ways of getting the app. You can either get the app for free, or you can get the app by paying a price. It turns out that if you get the app for free, they tend to make less privacy requests than the app that you pay for. In addition, the app that you pay for usually includes advertising. And so what these researchers found is that people, at least some people, are willing to pay a price in order to keep their private information private. So we see that people are making these trade-offs. However, there's a well-known privacy paradox in that people say they're much more concerned about privacy than it comes to an actual practice. And so that we all know, we get a new app on our smartphone, and it says, to use this app, you have to agree to the terms and conditions. Click here if you agree. Click here to read the information. Not to just click, click, click. I just want this app. I'm not going to read all this information. So this is the privacy paradox. And so then there's a privacy calculus, which is what we're going to study in this paper, which is how do people trade off the benefits and costs of innovative products such as UBI insurance, various other connected products, in terms of deciding how they adopt it, whether they adopt it, how do they use it, and that's what we're going to look at today. Now, in UBI, that I'll show you in a second, but in the data we have, an insurance company offers usage-based insurance to its customers. 30% of the people adopt the product. Okay, why don't everyone adopt it? Well, it's inconvenient to install the product, so you may not want to go through installing it. You may not, once you install it, keep it in your car. You may not sort of find it annoying to have it there. It's always there. It beeps when you hit the brakes hard and so forth. And so there's an inconvenience, a nuisance, and there's also this loss of privacy. So we think UBI is an excellent setting for studying the economic significance of privacy for several reasons. First of all, UBI is completely optional. That is, if you sign up for UBI or you don't sign up, you have the same automobile insurance. So the product is exactly the same. Okay. Secondly, unlike a lot of the smartphone apps, the customer knows exactly what information is being monitored. In the company's websites, in their brochures, they tell you what information is being monitored. Thirdly, the device can be removed by the customer at any point in time. The company has a policy of saying, the longest we're going to monitor you for is 6 months, but at any point in time up to that 6 months, you can remove that device. If you remove the device, you may get a lower discount, but you're free to remove that device at any point in time. And I'll talk about the dimensions of that. The other advantage of this is it's a direct economic benefit. You engage in UBI, you get premium savings. Okay, and the premium savings are quite substantial. In the company we study, just for signing up in UBI and being agreed to be monitored, you get a 5% discount, okay, off your total premiums for that company. If you stay with that program for 2.5 months, for 2.5 months, then you've passed your provisional period and the company offers you a permanent discount. You can drop out then and you get a permanent discount as long as you stay with the company. If you monitor as long as 6 months, then your discount can increase. And these discounts are substantial. On average, in the data we look at, the average discount is on the order of 12%. If you figure auto insurance costs $100, $150 a month, that's a pretty high premium. And as I said before, adoption rates are sufficiently high at 30%, so that we're not just getting a few technophiles trying this new product. It has fairly wide acceptance, but not so wide that everyone's doing it. So 30% seems to be like a very good level for sort of looking at sort of people who are not particular technophiles or not particular technophobes. So it's a good balance. So our research questions are, first of all, how do customers make a trade-off between their savings in insurance premiums and the cost of installing and continuing to use the UBI insurance? And that will include privacy, but other costs as well. But more directly, we're concerned about what are changes in consumers' perception about privacy? Do they have an impact on consumers' willingness to adopt the product, and once they adopt it, to continue using it? And we have about a 2.5-year data period, and fortunately for us, there were two major changes that took place. About 1 year into the program, into our data period, the company improved their privacy policy. Is that, when you install the device initially, so this device keeps track of where you go at all points in time. People might not want the company to have this information. They use the information, as I said before, to track how far you drove, when you drove, your speed, and a whole bunch of things like that. After a year, the company said, we're not going to keep the location-based information in any storage device in our company. Is that we're just going to use it to calculate miles per hour and things like that, and we're going to wipe out the location-based information. So that means the information is a lot more private because it's not there. It's there maybe for a few hours or a day, so it's not really stored. So that's a big enhancement to their policy. And then secondly, 6 months after that change, there was a major data breach event outside the company that affected 40 million customers of Target department stores, the second largest mass retailer in the United States after Walmart. And so while this company is not affiliated with Target, it got a huge amount of coverage, as I was showing. So these changes in privacy allow us to see what the effect directly is, both of enhancing privacy and decreasing privacy. Okay, so let's just see a little bit about how this program works. So I've outlined it. We're eventually going to build what we call a dynamic structural model, because we want to take account of the fact that when you sign up for the program, you can sign up right now, but you can drop out at any time, so that we actually have daily data. But for convenience, we're going to group it into 15-day or semi-monthly periods. And so you can picture that, okay, I sign up now, but 15 days from now, if I don't like it, I could drop out. Once I drop out, I'm out, right? But what I have another choice 15 days from now, and then another 15 days and 15 days and so forth. So I could continually, think in advance about what I'm going to do. So I have lots of options for future behavior. And so we take account of those future options when we eventually build our model. But first I want to just talk about the program and some overall results we get before we look at that model itself. So the timeline is our data period starts in March 2012. In June of 2013, there's this change, enhancement, and privacy policy that I talked about. 6 months later, in December of 2013, this external data breach event occurs. And then in about a year later, November 2014, that's when our data collection period ends. Okay, we think this is an unusual data set. We're incredibly fortunate that the company was willing to share this data with us. We have no personal information on the customers themselves, but we do have their records and information on where they live and things like that. We have a database of 135,000 customers who submitted a quote. And as I said before, about 30% of those opted for this program. So now I want to go through the UBI pricing strategy that the company uses, because that's important to understand why we're able to get results about privacy. So that initially, as I said before, the company tells you you have the option to have UBI insurance. If you do it, we'll give you a 5% discount just for signing up. And also, we'll guarantee that we're never going to use this information to increase your rates. So it's a win-win situation. You know, if you share your data, you'll get a discount. You'll never have an increase as a result of this data in your insurance rates. Okay. Then for the next 75 days, you drive. You know, every time you hit the brakes hard, you get a beep in your car to remind you that you hit the brakes hard. You shouldn't be doing that. They have an app. Every day you can look and see how well you're doing in terms of how many hard brakes, whether or not you accelerate, miles per hour, a whole bunch of things like that. Now, and so you can, we group our data into 15-day periods, but if you drop out in the first 75 days, you then revert to paying your regular policy. As soon as you drop out, you lose your discount. Now, after 75 days, what happens is that you get an updated UBI discount. And typically that discount is higher, but it may vary by person. And not only do you get this updated UBI discount, but if you drop out now, then you still get a discount as long as you stay with that company on all your insurance premiums. So you don't have to stay in this program any longer to get a discount. And so these are what we call informed dropout. So people who drop out in this period, they know their insurance, what their discount is going to be, and they're going to have that discount or maybe a slight adjustment if they stay longer in that program. And so you can still drop out, and people do drop out from week to week or bi-week to bi-week, but that's relatively low, and I'll show you the dropout rates in a second. And then at the end of the 180 days, by company policy, you return to the company, device to the company, and you get a permanent discount, which can be up to 25% and averages 12%. And very few people get no discount, like maybe 1-2% of people. So virtually everyone's getting some positive discount from being in the program. Just to look at what the data looks like, a brief overview. You can see that about 30% of the people adopt UBI. That if you compare UBI adopters to non-UBI adopters, one thing that stands out immediately is that the UBI adopters tend to be lower. We think they're lower because new drivers, also sort of younger in age, the UBI is particularly appealing to them because their initial insurance rates are typically very high because they don't have a driving history. You can see their monthly insurance rate is a little bit higher than the others. So it's particularly appealing to younger drivers. Interestingly, the fraction of males versus females who sign up is approximately the same. So there's no variation by gender over here. And then interestingly, what I talked about at the outset, if you look at the first year renewal rates, because generally, at least in the United States, you buy insurance for a year, unless very rarely do you switch insurance companies in the middle of a year, unless maybe you move from one state to another. But the first year renewal rate for people who sign up for UBI is 86% compared to 77% for those who don't sign up. So this notion that it leads to a higher renewal rate is really quite important. People who stay in this program for the entire 6-month period, we call those loyals. About 64% of the people stay for the entire 6 months. As you can see, that in the early part of the period, maybe 1-2% of people drop out. Then once they're informed, it shoots up to about 16-17% or so, and then declines down to, again, a very low level, more like 3-4%. So the main period of dropping out is after you're informed what your UBI discount is, and you have the opportunity to have that permanent discount. So for the sake of time, we're just going to focus on the informed dropouts as compared to the loyal customers when we look at results later on. Now, the other interesting point, we already talked about who adopts. You can see that younger people, the older you are, the less likely you are to adopt. But the informed dropouts, that the better your UBI score, the better your monitoring score, the less likely you are to drop out. So people who are doing well, or people who've improved more, they're the ones who are more likely to stay in the program. So there is some effect of doing well on staying in the program. Okay, now I talked before about these two privacy policy changes. The first one occurred consistent with industry-wide trends, that what happened was that there's a lot of concern about what's going on with this data that you have, and the company announced, as did other companies, that your location data would not be stored in the company's servers in the future. This greatly enhanced the privacy policy, and the company naturally asked its agents and on its website to let current and new customers know about this enhanced privacy policy. So the question is whether or not this has any impact on what people do. So if we just look at the raw data and look at what happens just the 2 months before the policy change and the 2 months after the change. So if you look on the left-hand side, you can see circles mean that there's a difference between the two columns. There's statistically significant difference. When they announced the policy change, there was immediate, and later on I'll show you it was a long-term increase in the number of people who adopt. So this enhanced privacy policy is a demonstration in the real world that you increase the privacy policy, and at least in this setting, more people join. Now, someone might say, well, that's just a seasonal effect. Maybe there's something going on from month to month or something like that. So then we look at the previous year, and as you can see in the previous year, that's grouped together, that there was no difference in the adoption rate. So this is clear but preliminary evidence, and our model will sort of tease this out more fully, that the privacy policy had a change on adoption. However, there was no change on the dropout rates, right? Before and after, as I said, every 2 weeks you have a choice: do you stay in or do you drop out? There was no change in dropout rates when they enhanced this privacy policy, so it didn't affect, at least in this case, existing customers, nor did it have an effect the year before. Okay, the second event that occurred was a data breach at Target department stores. This, I said before, this affected 40 million customers at Target, the second largest mass retailer in the United States. If you do a search on Google Trends, you can see that up until the time of the data breach, there are some searches for data breach, but very few in the United States on Google. And then this event happened, the data breach from Target, and the number of searches on the term data breach surged by a factor of 10 or more. So clearly this was a major event, but you can also see that the number of searches afterwards declined quite a bit. So it was more like a one-time event and sort of fades out in significance over a period of time. Okay, so now what was the effect of this data breach? Well, here, the effect was really quite different. First of all, as I'll show you, the effect was primarily on the informed dropout. So again, we look at the 2 months, or in this case, the month after the data breach and the month before the data breach. So you can see that there was a significant increase, right, in the number of customers who drop out after the data breach. So the data breach had an effect on the number of people who agree to stay in the service, or in other ways, the informed dropout rate. On the other hand, if you look at the year before to see, is it a seasonal effect, there is no difference in the seasonal effect from year to year. Now, very interestingly, this data breach had really no impact on the number of new customers adopting the product. So we have two different events. I know that that chart looks like it's big in the previous year, but that's just, it's still, the chart should really be a little bit closer together. So that unlike the data enhancement policy, and we're not saying it's going to happen for all cases, but each of these different privacy events affected the company in different ways. And that's why one of the reasons we think this data we have is so interesting, because we can look not only at whether or not you initially become a customer, but in this case, whether or not you stick with the program. So it's continuity and monitoring as well as signing up. Okay, now we want to try to structure this data a little more formally to better understand what's going on. So we build, as I said before, a dynamic structural model, which takes advantage of and tries to sort of understand how the consumer is making a decision. So the consumer is making a trade-off between the long-term price benefits of being in UBI versus the short-term cost, which one we call C sub 0, the cost of being initially adopting it, and C sub 1, the per period, and just for convenience, we make our period 15 days. The 15-day period cost of being monitored, because that device is always in your car. You're always giving up more private information. So that's the trade-off that we're trying to look at, which customers are making. We say that customers are forward-looking because they think I'm not only making a decision to install a device right now, but I'm making decisions, what am I going to do 15 days from now? Well, what's going to be different 15 days from now? Well, 15 days from now, you're going to have more driving experience. You're going to have a better understanding of what your UBI score is. And maybe my UBI score is improving, so that you look forward not only to the fact that you have another chance to make a decision, but your UBI score might be different. And that's a technically term, what people call state dependence. And so each period, and I'm going to show state dependence in a second, each period you update what you're, based on your current performance, and we're going to show how we model that. And you could say, well, you do have the option of staying with this company forever, but to be realistic and to conserve a little bit of computer time, we say that we're only going to take a 5-year horizon, but we've done some tests and we're pretty confident if you made the horizon shorter, made the horizon longer, it doesn't really have much impact on our main results. So we look at a 5-year time horizon, and obviously have like a present value discount factor that we set in advance to account for the future value of money. Okay, now, first of all, this obviously, and I don't want this to be a math-oriented talk, but there are a couple of concepts that I think it's really important to think about and sort of look at in a mathematical sense. So when the program starts out initially, we have this term D sub I0. That's your initial decision. And your initial decision, we set that equal to 1 if you adopt and 0 if you don't adopt. Okay. Now, once you've adopted, then each period you have another decision. The other decision is, do I keep UBI? I've already decided to adopt it. Do I stay in the UBI program, or do I drop out? And if I drop out, then I'm out of the program forever, because that's the rules. Stay in, as long up to 12 periods, 12 times 15, 180 days, or not. Now, what's your utility? What's your value of being in the program each period? Well, the immediate utility, now everyone gets the same automobile insurance coverage, so we don't have to factor that in. Basically, what we're looking at is sort of what's your cost of being in the program. Well, if you're in the program initially, so that alpha, which is your price sensitivity, so how sensitive you are to price times the premium you're going to pay, right, which is your first year premium, and I means for each individual, so model this because you have individual data at the individual level minus your discount. Now, if you're not part of the program, you don't get a discount. And so that's just zero. So you're paying full premium. If you are in the program, that factor is 1. And then you get a discount of 5%. So you're only paying 95% of the premium. Okay. But also, if you're in the program, you pay this first cost, the C sub 0 of signing up, of being in the program, installing a device, revealing your information, as well as, since it's for 1 period, this 1 period of monitoring, of allowing your activity to be monitored. Beyond the first period, then it's basically similar, except now we have to account for what state you're in, like how well you've driven in the first period. And then as well, you don't have the C sub 0 cost, but you have this continuing cost. And we estimate it with error, so there's an error term as well. Okay, what state are you in? Well, before you start, right, SI0, well, you know your premium, you know what your demographic characteristics are, and we know your insurance score. This is the general insurance score that a company calculates based on your general characteristics, as I said before. You know, useful, but not perfect. Okay, well, nothing's perfect. After the first period, then you know your UBI score. And then after the 6th period, not only do you know your UBI score, but you know your UBI score for the 6th period, which determines what your revised insurance rate is going to be. So that so you have those 2 different measures over there.
Call from the education.
So, so those are the different states that you're in. So those are the measures that you have. And then, not to blow you away with too much math, but here's how the process works, okay? So right now we start at the far left. I decide to adopt or not. If I don't adopt, I drop out, and that's the end of it. If I do adopt, then 1 period later, I have to decide, do I stay in the program or not? And I now know what my first period insurance score is. Then the next period, I have another decision to make. Do I stay in or do I drop out? And it keeps on going on and on and on and on until you've gone through 180 days, in which case the program ends. So you know in advance that you're going to have all these future options. So we apply the present value discount factor, which is beta, and we sort of discount not only the value of being in these future states, but we take account of what your best decision is going to be at each point in time. And if someone wants to, you know, examine more carefully, you know, how we model that, I'd be happy to discuss that offline later on. But I think I just want to give you the general idea of what we're doing. So that's the model that we make. The model is at the individual level. We look not only at your immediate utility from joining or not, but also your option each future period to decide to stay in the program or not, based on how well you do in that program. Okay, so that's the model that we estimate. We can solve this problem completely, and here are the results that we get on the bottom. So first of all, I said before, we fix the present value discount rate at 0.05% per half month, or about 12% a year, which is a generally accepted number. The price sensitivity is about 0.49 or about 0.5. And the first thing to notice is that we get a general result, we get a general effect that there is a cost of signing up in the program, the 73.92. And in addition, there's a cost of being monitored. So people are sensitive to the cost of signing up in the program, which includes privacy, but other factors as well as the cost of being monitored. We can translate this into dollar terms by using the price sensitivity factor, the 0.049. So the equivalent of signing up is equivalent to savings or a cost of $150 in the premium, and the 2 week cost of being monitored is about $16, $17 So there's a very strong cost, but these numbers are related to the fact that you're paying on the order of $1,200 to $1,500 a year for insurance, so that, these are big numbers in terms of privacy calculations, but they are important. Okay, so now what we've shown is that there's an effect of the cost of signing up, and there's an effect of being monitored. To what extent can we relate that to actually the privacy events that happen? Well, the privacy policy change was an enhancement, so that's green. The data breach was a negative effect, so that's in red. And if you look at this model, basically, there's also a time trend taking place. If you look at the model, so there's an initial cost, C sub 0, of signing up. When the privacy policy comes into effect, that's a benefit, which we measure by what we call tau sub 0 over here. So we take account of the benefit of the privacy policy. If the data breach occurs, then we say, because I showed you before, that sort of declined in intensity over time. So we say that only occurred for about 2 months after the data breach. So now what we do is we take account of the fact that the cost of signing up in terms of privacy may change over time. And what we want to know is whether or not the coefficient tau for the privacy policy and the coefficient delta for the data breach have a statistically significant effect. And that's what we've built up now to doing. And so let's look at the results. Okay. So if you look at the results, you can see, first of all, the coefficients that we had significant before are significant again. The price sensitivity is basically the same number that it was before. The effect of the privacy policy on adoption cost is negative and significant, which that means that the fact that they did this enhancement in privacy policy lowers the perceived cost of adopting the policy to customers in these terms by about -4. But also, if you look at tau 1, consistent with our sort of overall global look, but now much better control for other external factors and internal factors, there's no significant effect of the monitoring cost. Okay. On the other hand, data breach has a marginally significant effect, which we didn't detect before on adoption cost. It makes the cost of adoption higher because it's a data breach, and but more important and significantly, it has a significant effect on the cost of being monitored. So again, now we replicate with a much better controlled individual level model what the effects are of privacy policy and data breach. So we have an individual level model. So we might say, like, is everyone the same? Does everyone react in the same way? Well, clearly we can say no. We're certainly, some people are more sensitive to privacy than not, but can we look at sort of interesting ways of trying to divide up people? Well, one of the most interesting ways to divide up people, and there are other ways of doing it, but the way we're looking at least for right now, is by gender, by males versus females. And so first, let's look on the left-hand side in terms of the adoption events. And what you have over here is that when the privacy policy is enhanced, there's no effect of the data breaches we know on adoption, there's no differential effect. We find that the effect of the privacy of the data, the privacy policy enhancement, is that affects males much more than females, right? That their cost parameter goes down by -8 compared to about -5 for females. So males are much more sensitive to the privacy enhancement than females. And yet, on the other hand, when we look at females as compared to males, females are much more sensitive to the data breach events, and their privacy cost for monitoring goes up by about 50% more. So differential effects for males and females, which suggests that in future work, one wants to explore, why this differential effect might be occurring. And this is a subject for further research, but we haven't explore that at least so far. So to summarize, the other point I want to make is, so I showed you all these statistical numbers and these costs and effects, but then we all want to know, at least I want to know, and my colleagues want to know, is does this have a real effect on the company? So we can do what's called a counterfactual analysis. We can say, what if the company hadn't made this policy change? What if the company had said, we're not going to enhance the privacy policy as compared to what they actually did? So what we can see here is that up until about June 2013, they didn't change the policy. In June 2013, they changed the policy, and that's the blue line, right? And you can see that when they changed their policy, consistent with the cost estimates that I showed you before, the number of people adopting the product, adopting UBI, went up significantly. What if they didn't do it? Well, that's the dashed line. If they hadn't made this privacy policy change, excuse me, then you can see that their adoption rate, while it still goes up over time, it would not have gone up nearly as much. So that in the real world, making a change in their privacy policy enhanced consumers' privacy, it affected their adoption rate, and so you had an increase in the number of people who were adopting the product. If we look at some other figures, you can see that it affects not only adoption rate, went up from 0.92 to 0.32, percentage of customers who stay in the program for the full 6 months, which is what the company would like, that also increases. It also increased the adoption rate among young drivers. So it had a lot of effects. Now, one of the interesting questions is whether or not when you adopt this privacy policy, who does it affect? Could it affect mainly safe drivers, like who are just reluctant to sign up to the program because they don't want to release their private information? Or could it affect a broader class of drivers, maybe less safe drivers who are doing, I talked about before, this privacy calculus, trading off the value of being in the program versus the cost of being in the program because of privacy cost. And so interestingly, we see that the people who sign up with the new privacy policy tend to be drivers who have scores which are not as good. Their initial insurance score, their initial UBI score is somewhat lower. So that the company should recognize that in fact, that this policy, that they adopt this privacy policy, it's not only going to increase their adoption rate, but it's also going to be attractive to drivers who may be less good. Now, this is not a negative for the company's profits, because as long as they know, and that's the main point, is personalized marketing, if they know what your driving record is likely to be, or can make a better estimate of what your future driving performance is going to be, then they can better target their products, they can adjust their pricing for these customers. So now let me conclude by summarizing. So first of all, by having this data, by looking at UBI, which is an example of these new connected products that use individual level data to design personalized products, that there is a cost to consumers of adopting these products and of continuing to be monitored by these products, and this affects their acquisition and continued usage of the product. That in our data, at least, the enhanced privacy policy seems to lower the adoption costs for consumers and hence increases the adoption rate. The data breach primarily affects existing consumers and decreases their continued usage of the UBI product, so the effects are differential. And there's heterogeneity in terms of how people respond. Females are less sensitive than males to the enhanced privacy policy, which affects the adoption rate. But females are more sensitive to the data breach than males, and that affects the dropout rate. It clearly indicates that consumers companies should be sensitive to the impact of their privacy policy, and empirically demonstrates this, not only in considering the adoption, but the continuing usage of it. And thirdly, I want to note that we're continuing study with this company, but now we're having a new opportunity to look at another data from another company, which is going to allow us to look at the issue of mechanism design. That is, how should the discounts be set? How long should the monitoring period be? And so looking at these mechanism design issues, we think are important in developing effective ways and better strategic ways of seeing how people and companies can cope with the concern for privacy. So let me close by saying again, muito obrigado. I hope I pronounced that correctly, but I really very much appreciate the chance to be with you today. So thank you very much. Bye-bye. Aside from now, I'm turning it over, and I'm more than happy to answer questions that arise.
Just before starting the questions, it's my fault, my mistake. I did not present the co-author of this paper, Maryland Soleimanian. He was with us, and I didn't saw him. So please, sorry about that. I didn't present you before. Okay.
All right.
So Danny,
can I take this over? All right. Professor Chuck, thank you. Well, Professor Weinberg, I mean, I'm going to call you Chuck.
Call me Chuck. This isn't even formal.
It's just a way of, you know, making it more formal. But let's break.
They believe we met in a bar at the conference,
right.
And we're relaxed, right?
Yeah. I missed the drinks, like I told you.
It's only 10 in the morning here.
Right. No, for us, it's already like we can have a drink down here, like 2, 3.
Well, I'm willing to adopt a local custom, so I'll drink.
All right. So thank you very much for your presentation. I really appreciate learning more about this topic. Like I told you before, I read your paper together with your co-authors, Maynard. And I thought it was so interesting because some of the implications went actually beyond, you know, marketing and addressed actually implication to society. So UBI scores would also imply that people would drive better on the road, meaning less accident. And so I thought it was really interesting, and I really wanted to pinpoint this in the beginning, because in this new paper, which is, I understood that it is kind of like a series of papers using a similar context, you addressed also very interesting research questions. So having said that, that I really enjoyed, I really appreciate your presentation, really enjoyed the topic. I have some few questions just to warm up. I'm sure that there are more questions from the audience, but we could start like this. One thing that came up while you were presenting, you know, you focused on the renewal rate. Because of course, I mean, I can expect that the insurance company is really keen on, you know, keeping their customers, you know, making sure that they renew the insurance policy with them. But I wonder how much of this UBI score affected people filing claims, you know, like people getting involved in customers getting involved into, you know, accidents, because this could also mean that it's not only like a matter of keeping your customer portfolio, you know, the size of your customer portfolio, but actually it's getting rid of the bad side of the customer portfolio. So getting rid of the customers that are actually claiming more, filing more claims. So I wonder how you dealt with that, because I'm sure that you, well, I'm not sure, but you might have had also access to the claims. Could you just make a comment on that?
Sure, I'm happy to comment on it. First of all, you know, I wish we had access to the claims data, because that would give us a better measure of how long the effects of UBI actually last. But while we don't have access to the claims data, we do have access to the insurance score, which the company calculates based on driving history. So in one sense, we don't have direct access to accidents, but we do have access to the insurance score 1 year and at the time of the first renewal and the second renewal. So it's like 6 months and a year and a half after you've been monitored. And what we find is that if you are a better driver while you're in the program, you tend to have a better insurance score. Now, it's far from a perfect measure, but at least it's suggestive of that type of behavior. And we also, not in this paper, but in the previous papers, I said, we do know that for sure while you're in the program, that you become a better driver. And what we found out that becoming a better driver depends not only on the economic incentives, getting a lower rate, but also on the information that you get, which, when you get the beeps in the car, and so when you get beeps to say you've hit the brakes hard, you get that information. Based on that information, we seem to see data which suggests you become a better driver. I won't say it's entirely cause and effect, but it's highly suggestive of that type of behavior. And this, if I then can expand, this brings back to this issue of this trade-off, which we examine in this paper, of the value of giving up privacy. Because UBI, we're fortunate enough to have this very big database, and strictly speaking, our results only hold for UBI. But it's very hard to get data on people's use of these personalized monitoring devices. And so, as I said before, like the UBI is like a Fitbit for cars. And what we find here is that people do make a trade-off. Giving up your private information, right, appears to be costly to people. It's not just what they say. It's not just in the computer world, but it's in standardized long-term, if you want bricks and mortar products. I know insurance is more of a service than a bricks and mortar good, but it's a traditional product, and companies are adding data connection, personalized information to it. And this is clearly what's happening across a lot of product categories. And so people gain from this personal interconnection, but there's also a cost, and people are doing this privacy calculus to say, should I stay in or should I not stay in, or should I use or should I not use this product?
Yeah, right. Yeah, thank you. Yeah, this is a very critical issue, I would say. There was another day that I was talking to my brother, and my brother works in the health industry, and we were actually talking about, well, it was before the pandemics anyway, but we were talking about having a good healthy life and for life, right? And in some way we have to change our behaviors, right? I mean, we need to exercise, go practice something frequently, and you need to eat healthy food and so on. Some of the health insurance companies are actually having people monitored in a way that they could, avoid having customers filing claims. And I would say that let's say the externality of that is actually that people are going to have a healthy life. Health insurance are actually helping people change their behaviors, and that's why I was wondering, I mean, how much we can say based on your study, how much people have changed their behavior in traffic, and I'm sure that in Toronto as well as US and Sao Paulo and Brazil, many capitals, traffic here is horrible, and people tend to get really aggressive every now and then, which is bad. And I think that this kind of like UBI monitoring would help saving lives. So and then following up on my on your last comment, I wanted to understand a little bit about this trade-off you posed, and this is actually one of your research questions, and very interesting, by the way. You said about price discounts, and you calculated C0 and C1. I was wondering, when you said about price discounts, I was expecting that you were going to show, and maybe you showed and I missed that in your presentation, but what is the elasticity? I mean, how much the insurance company has to provide for insurers, for customers, to get access to their data? I mean, you provided us two figures, $150 and $16. Help me understanding, I mean, how your model predicts this kind of like a price discount, how much I mean, the insurance company has to pay 24, and I see that it's 12 on average, but I wonder if you were able to actually get a kind of like a grid or something like a way to calculate how much discount you have to offer for customers to adopt, and most important, to change behavior.
So I think that's really a good question. I mean, I think like right now, what we have is, as you say, that basically like the trade-off is that people say roughly a savings of $150 in premium is equivalent to the cost of signing up for the program, right? And then there's an additional cost of being willing to stay in the program for a period of time. Now, initially, it's an interesting marketing question as to whether or not, and this we hope to look at in future research, is you have this policy of saying, everyone who signs up gets a 5% discount right at the start, or if you can adjust those initial discounts by some of the characteristics of the driver. You can see, like, after 75 days, which is only like 2.5 months of monitoring, right? The company now feels they know enough to give individualized discounts, because each person gets their own discount based on their actual driving behavior. So a relatively small amount of information, right, can be used to personalize the discount. Now, whether or not they should try to make some guesses early on as to how they should individualize it, I mean, that would be an interesting question to study. We don't have an answer to that, but I will point out that, while it's much easier, I think, from a marketing communication standpoint to say, if you sign up, you're going to get a 5% discount for up to 6 months or up to 2.5 months, no questions asked, as compared to say, if you sign up, we'll make a calculation and tell you what your discount is going to be. So that even if there, like some value, some market segmentation value, individualized person value of saying what your exact discount is going to be, it may not be the most effective strategy to do in terms of being able to make a clean offer to someone. I mean, this is really a clean offer, right? This says 5%, we're never going to raise your insurance as a result of this. Do you want this 5% deal or not? And then their strategy is, what you're suggesting over here, is 2.5 months later, then we have a totally individualized price based on your driving record. And also with the offer, if you like that, take it down, right? If you don't like it, right, then you can stay on for up to 6 months and try to get a better rate. So it's basically saying, we're making all in your favor.
Right. Yeah.
I mean, I don't know the answer, but that's the trade-off, I think, for what they're making.
Yeah. Thank you very much for all the answers. I would I mean, I have more questions, but I would like to invite more people to join. I'm sure that there are more questions from the audience.
I see there's some comments on chat, but
Oh, I couldn't.
maybe you can use that.
We don't have a large group, so probably we can address the questions by ourselves. Could it be easier, maybe? Professor Lucy was raising.
Yeah. Let's see if I have this. Okay. Well, good afternoon. Thank you very much, Chuck, or Dr. Weinberg. Anyway. But I really appreciate your presentation. But I have not one question, a set of questions. What are the impacts of the findings to the companies? You know, would it have increasing acquisition of customers, retention of customers, potential liabilities of claims and redemption of casualties? And also, sorry, I don't know how you call this in English, but it's the reserve that you have to make for casualties. Insurance company have to do this. How would this findings, the UBI, impact companies?
So I have several answers to that. At one time in my life, I was trained to be an actuary, so I certainly know about reserves. So that was well stated. So, you know, in the data, right, you know, is that what we know from our data is that, you know, when the company made a change in their privacy policy, they're able to acquire more customers. So that the immediate answer to your question is yes, it had an impact on the company's competitive position in the marketplace. Now,
is this potential or real?
It's real.
Oh, real, okay.
It's real. I mean, in other words, I mean, you can't, you know, relive the world twice, but like the counterfactual analysis and the advantage of the detailed analysis that we did is that we could ask the question of, you know, what would happen if they hadn't made that policy change? And so everything's with some degree of error, but it's pretty strong evidence that they have, you know, approximately 2% higher adoption rate as a result of this policy change. Now, whether or not, you know, and we also know from our data, right, is that people who sign up for this program, right, are more likely to stay with the company. So the 1-year renewal rate is also higher. That's not as fully statistically controlled as the adoption rate, but it seems to be a general trend. So I think we can fairly confidently say that that having this policy and having this privacy enhancement, you know, benefited the company. Now, whether or not this translates like immediately into changes in their reserve policy, how much they keep on reserve, I mean, that's a, you know, very complicated regulatory requirements. So I really can't make an estimate about that. The other interesting question, which I'm inferring from what you asked, is that, so if the company follows this policy in the long run, then you have people who join and have this policy and people who don't, right? So then the people who don't, right, are going to be people who tend, there are two classes of people who are not going to join. Those people who are bad drivers and know they're bad drivers, and they know sort of being lumped in the average is better for them, right? And the other group of people are people who are just very concerned about privacy, right? So that people who are very concerned about privacy, this may have an adverse effect on them because they're not signing up because they're really seriously concerned about privacy, but they're good drivers. And they're going to have to pay slightly higher rates. So there's like a social dilemma involved is that, you know, personalized marketing of this type, which uses private information, right, is beneficial for people who are willing to make this trade-off, who can perhaps become better at improving their health or at driving their car, or whatever the activity is, benefit from getting better products, right? And are willing to make that trade-off. But those who are not willing to make that trade-off, right, either because they see no benefit to themselves or because they're so concerned about privacy, they're going to, in the long run, possibly end up having to pay a higher price or getting a product which is less attractive. So that's a long run factor that needs to be taken into account. And as yet, I haven't seen studies that have looked at that issue, but I think it's an important public policy issue to look at.
Thank you. Thank you.
I'm gonna offer also a chance for people who are not so comfortable in this kind of like online setting. You guys can write down questions in the chat, and we can try to address them to Professor Chuck. So if anyone has a question but is not so comfortable in addressing this online, just make sure to use the chat. Is there any other question from the audience?
Vinicius Bray, you want to talk?
Where is he? Oh yeah, go ahead.
Professor Chuck, thank you for the very inspiring talk, and congratulations to you and to your co-authors for this great research. I should say that I wasn't very comfortable with the takeaway that older males have more to hide, but we'll continue with my questions. One of the things that I was thinking about is that in the term of your model where you update the states, I see that the data breach has a very strong role in the model because it seems to be a unique event that has affected a lot the overall behavior of the customers. I was wondering if that specific term, if it shouldn't be updated more frequently in order to dynamically take into account the changes that we are seeing now and then about breaches, data breaches, password breaches, and different types of privacy issues that are much more common and frequent than we used to see. And I'm sorry if I didn't get correctly this part of the model. I just saw it very quickly. But it seems to me that instead of using just one event as a major parameter for the state update, it would be better to dynamically recalculate it every month, for example, using one type of, say, Google Trend Index or any Google Search Index, something like that. Just, I'm sorry if I, again, if I have not, yeah. So this is one first comment, and I'm not sure if you or the authors have thought about this issue. So I have other issues that I'd like to comment, but if you want to say something about it.
Sure. So so first of all, it's a great insight into the model. You clearly understood what we were what I was trying to present. So that was really good. I just want to say at the outset that we're not saying that older males have more information to hide. First of all, males and females are about equally likely, given their percentage of drivers, to sign up for this program. And secondly, it may reflect rather, you may have the same information, but older people, whether male or female, may be more concerned about sharing their information, not that they have more information to hide. So we don't know whether or not they have more information to hide. It's just that they're more concerned about their privacy. So just to clear that up. So your point about how we handle the data breach is something we've spent a lot of time thinking about, and you're quite right in your characterization of the model. Is that what we say is there was one major data breach event. When that major event took place, there's a sharp rise in the attention in Google Trends. And then we say, it declines, fairly quickly after that. And so that's why we just model that one trend. But it would be feasible to consider it, and my co-authors and I, I'm sure we'll look at that again, to say whether or not, that data breach was a major event. That stands out, and that we think is unique. But we could have considered a second variable, which, after the event, represents like a higher but continuing level of concern about data breaches. And so, that could be a factor. We partially account for that already by having a time trend variable in our model. So if there's a general shift in more concern about the data breach, that would partially be reflected by our time trend variable, but we will reconsider that factor. So thank you for that insight.
You're welcome. Thank you. I have more comments, but I will let the others, if there is more time later, I have some other comments or questions, but I don't want to be the only one to make questions. So please, Danny.
Thank you, Vinicius, for the question. I just wanted to jump in because I also wanted to hear some thoughts about this data bridge variable that you added into the model. I thought it was a very interesting, addition to the model, considering these external factors. But I was wondering whether, there is this Kevin Mardy paper in Journal of Marketing talking about data privacy, and they actually they have this event study. And one of their hypotheses, they actually take into account whether or not, a company that is a rival company and had a data breach, other companies in that industry will actually benefit from that, so in that, if one of the insurance company get involved.
Can you hear me? It just froze.
Hello? Yeah.
Yeah.
Can you hear me?
Yeah.
All right. Yeah. So, so my question is basically like this: if another insurance company gets involved into this data breach problem, if they have a problem with the a leakage, I wonder whether, this would be actually a positive effect in this context, rather than a negative. The way I see the coefficient, if I remember correctly, it was a negative effect. And I like, I like the idea of having a different way to measure the data breach rather than just a dummy variable. Would be helpful to inform more the, how customers will react to that thing.
Sorry, I think Chuck is disconnected. Is not here anymore.
No. Well,
can you hear me now?
Oh,
yeah, I can.
Chuck.
Sorry.
Okay.
Chuck, did you hear my question?
Yes, I heard your question.
All right, thank you.
So we don't know, what would happen. I think it's really an interesting question. I know that article, and the interesting question would be, if there's a data breach in a company that's similar to yours, right? Would it be a benefit to you because customers would go from that company to your company? Or would it be a negative because people would say, well, if it could happen to company A, it could happen to company B because they're basically in the same industry. I think one of the interesting modifiers, if we were to examine that question, would be consumer trust in the company. Because if consumers have a great deal of trust, if you've built up a strong consumer goodwill, then in fact, what might happen is that, if you had a data breach, if you explain well why that happened, what you're doing to correct it, then people might still stay with you. If it was a company that was in slang terms, somewhat sketchy, that you weren't quite as confident in, then you might be more inclined to leave that company. So I think further studies on intra-industry effects are certainly worthwhile. It's in some ways our results are quite surprising because you here have a data breach. It's a major data breach, but it's completely outside this industry, right? And it still affects people, in the automobile insurance industry who are being monitored. And it has a very direct effect. It only affects, at least in our data, current customers. It doesn't even affect existing customers. So we found that really quite a striking result. But better understanding, under what circumstances data breaches affect companies as some companies as compared to others, or whether or not holds within industry. These are really fascinating research questions.
Yeah. And since you have a very unique and very detailed disaggregated data, I mean, it was very interesting that you added such a kind of like a variable into the model. And indeed, it's not that strong, but come on, it was Target. Target is a supermarket. Doesn't have anything to do with insurance, right? But
Exactly.
people become more aware and more concerned about the issues of their, personal data. And it was also another thing really interesting in your model when you added the changing in privacy policy, and that one is pretty strong compared to the data breach. And I think it was very interesting. And I just wanted to ask you about the counterfactual analysis that you ran. I mean, how did you estimate the other curve? I'm asking because I want to learn. I have a reviewer chasing me since I have a dummy variable like you have in your data and model. I mean, how did you estimate the other curve?
Okay, so there are two parts to the answer. So we have what we call a structural model, which allows for it starts from primitives, utility of how people behave, and so that's the underlying foundation. And then given that, we just said everyone stays the same except if that dummy variable, which is, as you say, is now 1 for being, after the privacy enhancement, if we turn that to 0, what the results would be. To convince a referee, and I have to say, we're still in the revise and resubmit stage, so we haven't convinced the referees yet. But it's sort of the build up to the structure and sort of persuading the referees that in fact we are really capturing the dynamics and of how people are making these decisions. And that's why we have such a complex model.
So you estimated the second half based on the previous half model. Is that you're saying? The 0 and 1,
Well, we based, what actually happened is based on the complete model data, right? And the second part, after you get the break, so that's where the dummy variable went on in technical terms. And then we do another estimate where that dummy variable is 0, but the other characteristics of the people are the same.
I see. All right, thank you.
And we'll have a paper in hopefully a few weeks. So if you send me a note, I'd be happy to send it to you then.
Sure, great, thank you. Any other question from the audience? We still have some time.
I have one question. Probably I don't know exactly if this is important for the model, but the utility from each individual, which is gaining discounts in each state, in each different state in the model. If there's some information about, because you probably have information, you received information about how you're driving, and if you maintain your discount if you drop off in the middle of the problem, or your discount you lose your discount when you drop off. You maintain, So the thing is, probably I get information about my driving behavior. So there's maybe a utility calculus there that I made, maintaining me in the program or just drop off because I know I will have some issues because of my driving behavior. This part of the model, I probably didn't understand exactly why it happened, but how you model this kind of thing, or this is not important for the model?
Well, it's a part of the model for sure. What we say is that people anticipate, what they're going to do next. I can give you like a different sort of example. Today is Friday. I like to play golf. I really like to play golf on a sunny day, but given my age, I can't play for 2 days over the weekend. So if I can play on a sunny day, that's a 5-star day for me. If I can play on a cloudy day, say it's a 1-star day, I can't play it all over the weekend, that's 0, right? So now, if I wake up Saturday morning and it's sunny, I'm gonna play, that's 5 stars for sure, right? That's what I'm gonna do for sure. If it's rainy, I'm not gonna play because I don't wanna play on a rainy day. But if it's cloudy, what am I gonna do? Well, if it's cloudy, it depends upon what I think the weather is gonna be the next day, right? If I think there's a high chance it's gonna be sunny the next day, right? Then I'm not gonna play today, right? Of course, I don't know if it's gonna be sunny the next day, but I do know that if it is sunny the next day, I'm gonna play. If it's rainy the next day, I'm not gonna play. And if it's cloudy the next day, I'm gonna play because I'd rather play than not play. So now when I decide whether or not I play today when it's cloudy, I recognize that there's a chance it'll be better on Sunday or it'll be worse on Sunday. So when I make my decision now, I'm thinking about what the weather forecast is gonna be for the next day. So that's, I hope that gives you a sense of what we're trying to do.
Okay.
Does that answer your question or?
Yeah, I was thinking about how to model this exactly on equations, but that's probably, I can see the paper after that, so it could be better, yeah.
Can I?
You can just go on here, man.
Sorry, Chuck. Can I add a comment here?
Sure.
Yeah. First of all, hello everyone. It's my pleasure to be here. I didn't have time to introduce myself. So that's a really good question. And this is the nature of our model, that we are modeling in the dynamic way. So each customer has an expectation about the future performance. And we model that in the state space that we have. So in each time period, the customers consider their current status and also their expectation for their future. And based on that, calculate not just the immediate utility, but the valuation function, which is the expected utility that they can get till, for example, the end of the time horizon. So, and this is the way that we calculate that. So not just the immediate utility, but based on your expectation. And in each time period, based on the observed performance in UBI, you can update your expectation. So for example, you have an expectation that whether you are a good driver or not, what is your expected UBI score in the future. In the next period, when you observe it, you can update that. So what it happens. And we have a transition matrix. We estimated a transition matrix, and it gives us that expectation for each customer. So you are, for example, on the second month on period 5, and right now you wanna estimate and see what is your forecast for the next period. So and you use that transition matrix in order to forecast that, and based on that make your decision. Sorry, Chuck, that I interrupted.
That's good. Thanks, Miriam. Maybe better than my golf example.
Thank you for the answer. I like to play golf, so I probably like the answer from the golf one. So
yeah.
Hi, Danny. Professor Charles, I'd like to, I'm wondering in a different perspective, if this kind of research, this kind of variables you have used in your research should be perceived differently in another country. For example, in Brazil, when you're talking about privacy concerns, and even if you have some kind of data breach or different events, external events. We have measured here in Brazil that people, they have privacy concerns, but the privacy paradox is very interesting. They're still risking. If people were not stolen, they have the privacy concern, but they still using and trying. So I don't know, the effects is the same one perceived as in Canada or US. So it should be very interesting if you know to understand about this. We have the kind of environment, and we need to have some events, external events, how this change the perception of people, because in different cultures, the people want to try and they risk because they want to in some way to consume. Even if they see that it's dangerous, but it's okay. Nothing will happen with me.
Well, I mean, I agree. First of all, there will maybe you know, cultural differences or nationality differences in how people you know, respond to privacy threats, and so it would be interesting to see in different countries what trade-offs people make. The point is that you know, like what we're suggesting is that people are making a trade-off, right? That you know, I still have privacy concerns, but I agree to do some things, right? Because it's just either so valuable to me, or it's going to be so much fun, right? I mean, I want to play, you know, it's one of these interactive video games with a bunch of friends, or strangers, but to do that, you know, I have to give a lot of information. Or you know, if you're single and you're on a dating site, well, you know, I'd like to have a date, so, but I have to give up personal information about myself. You know, what's the trade-off going to be? So people are making these trade-offs, and that's what we're trying to actually capture in our model. You know, whether or not, to what extent people are willing to make these trade-offs. The behavior eventually is, you know, for automobile insurance, you know, yes or no, you're on the UBI program, but it's shaded in the sense that you can drop out at any point in time that you want. You know, if you drop out in the first 2.5 months, you don't get a discount, right? But
Okay.
once you get this information after 2.5 months, we see a surge in dropouts. So there are clearly people, you know, who are very similar to what you're describing. You know, I'm willing to take the risk. I want some benefits, but I'm not going to take too much risk. And so after 2.5 months, 15, 16% of us, that's it.
Okay, it's a kind of limitation about what they can risk or not.
Exactly. How risky do you want to be?
Yep. Thank you. I think I saw in the chat, Professor Marcos was writing something, Danny. Take a look if you want to talk.
Yeah, I saw that. Just check, there's another question for you. It's about the data. Someone is wondering whether you have more data at the customer level. So you said something about gender and age, I think. Are there more data there, like personality or, you know, whatever, the, you know,
No, we only have, if you want, so-called hard data. So we have things
demographics.
like age and gender, you know, what geographic area somebody lives in. So factors like that. We know things about what, and you know, what premium they're going to be charged, what their insurance for is. But we don't have personality measures because, at least in the United States and Canada, you know, the insurance company doesn't formally collect personality data in terms of setting rates.
Right. In your, it just now came up this question. In your dynamic model, information like female, male, like gender and age, they don't change over the window of time that you were studying. I wonder, I mean, in the end, it was accounted anyway, right? It was not a fixed effect or random effect. I mean, I don't know whether your model is bounded by this kind of like type of data.
Well, I mean, the model includes that that data. Obviously, there are a number of variables, like in our state dependency, which don't, as you point out, change from time to time. So that if you're age 33 at day one, then basically we're assuming you're age 33 throughout. What really changes from period to period, is your is, for example, your driving score, right? And based on that, what discount you're going to get. But we can group people, by age or by gender to be able to investigate, if they behave in different manners or react differently to privacy concerns.
And one more thing is in estimating the transition probabilities, we consider different estimates for different, for example, genders, for different age groups. So, and in this way, to some extent, we consider the differences that exist. So the transition that you have from one state to the another state, we try to separately estimate for different groups of customers.
Like subsamples.
That's
breaking
right.
the samples. Yeah.
Right.
Yeah. All right. Interesting. Well, I mean, we are almost getting to the end. Is there any other question from the audience? I think we might have like time for one.
Do we still have time?
Yeah, Vinicius, go ahead, please.
Oh yeah. So it's interesting because I was thinking about this. It seems that there is a threshold in each customer's mind that he or she will think about when to adopt, weighting the advantages and the privacy issues. So this trade-off seems to be very clear for this dynamic model. I wonder if the subgroup analysis would be the best way to do that, because each and every individual demographic variable should be a moderator of this threshold. So, by the way, I don't think we need psychometrics because we have the driving behavior, which should be a nice,
right, yeah,
a very good proxy for personality. But anyway, my question is: it seems to me that there is a kind of convex threshold, and when we think about this advantage and privacy balance that each and every customer will probably think about whether to adopt or not. Do you have a clear estimation about which variables were the greatest weight on this threshold calculation? I might be, you probably use the utility function to calculate that. I'm naming it threshold. I'm not saying if we are on the same page about it. But at the same time, it's interesting to me because my question is that if the customer knows how this data, how his or her data will be used to recalculate his insurance, this might backfire because I might start talking with my neighbor. Well, I'm gonna get that much discount. What about you? And then you can create it can backfire for the company, if you know what I mean, in the sense that people might be saying, well, I am a better person than you are.
Okay, so let me
just some broader thoughts and about
I think it's like it's an interesting question. I mean, to start with another field like airline pricing. So originally, like airlines engage in this sort of yield maximization strategies where they change the pricing all the time, and they felt customers would just react to the prices. But then the world changed when customers realized, well, if you're going to change your prices, I can wait, so I can play a strategy game against you, right? So that, and so I think at least the last question is really directed to this issue, is that, what would happen if people start to think strategically about how they behave, and they might behave in different manners. What one of the things we did find in the previous study is that if you look, it's not quite your question, but I think it's appropriate, that, as we said, people became better drivers over time. But they did most of their improvement at the initial point, and then they just held pretty steady, right? And that would suggest, like, if you're really gaming the system, you would sort of slowly get better and better and better and better, and you wouldn't have this sort of slow. And it also, we have some evidence that extends beyond the monitoring period. So at least in that setting, we didn't think people were just responding to the fact of being monitored, but that's always an issue. You know, whether or not, you know, one of the advantages why do companies sort of adopt these personalized technologies? Because it gives them a competitive advantage, because I can give something that another company, you know, can't provide. And then, you know, other companies can look at it and say, well, is that like a unique ability of that company, or can I also offer this type of product as well? So that, you know, over time, the competitive advantage that you get from UBI may tend to dissipate. Now, some of these advantages, you might say, the cost of acquisition of new customers is costly, and that, well, it has a very high expense, and that, you know, maybe, and this is just sheer speculation, that the savings to the system is not only from individually targeting rates, but if people tend to stay longer with a company, then you get higher retention rates, and so you have to spend less time both on dealing with customer churn. But that's just speculation as to what's going to affect. You know, will customers talk about what discounts they get? They probably will. You know, will it be comparing companies that adopt it or don't adopt it? Like when we're doing this project, I told my daughter what I'm doing, and she said, well, you know, my insurance agent calls me and says I should think about it, but, you know, I'm just too busy. I don't really want to deal with that. And so, you know, she's making, I think, a rational calculation. I mean, she's like, you know, a working parent, like lots of people. At a certain point in time, yeah, you could sort of install this device and get the savings. But, you know, compared to, you know, how value her time is, she doesn't want to spend the time getting the device, reading the instructions, and so forth. So I think people are making their trade-offs and doing that. So there are lots of interesting questions about, you know, how people are going to react both in themselves and how they talk to other people as well.
Great. I'd like to thank Chuck and Marimed to join us today. It was a great talk, great, you know, insights you brought to us. I like the discussion, the points raised, and I have to finish. I already received a message that they are going to close the room. So unfortunately, the time's up, and I have a measure of success in presentations. Every time that we run out of time, it means that, oh my gosh, this is a very good you know, talk, and I'm happy that Chuck, you arranged the time to be with us today and share the, you know, your experience, your research, and I'd like also to thank everybody who joined the seminar today. It was a great pleasure to have you all. And having said that, I think, yeah, clap hands. That's great.
Thank you very much.
Thank you very much, both for
Thank you very much.
myself and for my colleagues. We very much appreciate the chance to share our research with you. And as I said at the outset, we hope sometime in the future to be able to in Brazil in person.
Great.
And further share our work and get to actually know people personally. So thanks again very much. I really appreciate it.
Thank you. Thank you.
Thanks,
Bye.
everyone.
Bye-bye, everybody.
Bye-bye.
Bye-bye.
Thanks,
Thank you.
everyone.
Thank you, Chuck. Thank you. Thank you.
Bye-bye.
Thank you.
Bye-bye. Bye-bye.